All right. So this is the start of the new unit. So we're in Unit 6 now. And that is what's called Basic Integration and Application. So starting the first section today, we're going to find the antiderivatives / indefinite integrals of polynomial type and trigonometric functions. So again, it's going to be referred to as the antiderivative at first, and they're just going to start calling it the integral. The integral and antiderivative are interchangeable. They're the same thing. So I don't know what you have heard about before, if you've heard people talk about it prior, but we're going to be getting into the integrals now. So we're going to get definitions about it, but it's kind of like moving backwards compared to derivatives. Okay? So first things first, if you had to explain to someone how to find the derivative of a polynomial type function, what would you say? So 2 steps. If I have something like, let's just say x squared, that's a polynomial type function, how would you explain to somebody how to take the derivative of that? If it was something like that, go ahead.
You take the 2 and put it in front and subtract 1 from it.
Subtract 1 from what?
The exponent.
The exponent. So I'm going to put this up here so it may be a little easier for you to read. The 2 steps, you would multiply the coefficient of each term by the power, so x squared. Whatever that power is, you multiply it as a coefficient, so it was 2. And then, as Daniel said, you subtract 1 from the power of each term. So again, if you want to provide an example there, just to remind yourself, you can put like x squared plus x to the third and actually show the derivative of it. So again, this is what we already know. We already know how to do this. But now it says to find the antiderivative, you would do the opposite of each one of those operations and in the reverse order. Therefore, to find the antiderivative of a polynomial type function, you would have to do these 2 things. First thing, add 1 to the power of each term. We're just getting started, Braden. We're on page 333. We just started mentioning about antiderivatives, which is thinking about a derivative backwards. So we listed the 2 steps at the top about how we've taken a derivative. That's what we already know. And we're just starting to list the steps of doing the antiderivative, so the derivative backwards. The second step is divide the coefficients of each term by the new power. Divide the coefficients of each term by the new power. So the next little bit here, the antiderivative of a function f of x is denoted by the notation. This sign in front of the f of x, this is the integral sign. So that sign right there is the integral sign. The f of x is what's known as the integrand. So just some terminology. Integral, integrand, and the dx is your variable of integration. So the integral, the integrand, and variable of integration, the 3 parts. So when finding the antiderivative of a function, you are finding the function of which f of x is the first derivative. This will enable us, if given f prime or f double prime, to be able to find f. However, if the integral of f prime of x dx is equal to f of x, what problem do you foresee? So I'm going to give you a minute to think about that. Think about what you know whenever you take derivatives. Think about different polynomial functions in your head. What happens when you take derivatives of certain pieces of functions? What happens to those pieces? And then try to think, if you work backwards, what problem could we run into? Dan?
If, like, say you have that 2x squared, say you had like the original function was 2x squared, x squared plus 3.
Okay.
Whenever you take the derivative of that, you get 2x. You go backwards, then you only get x squared. That 3 is gone.
Exactly. So when you had a constant, you took the derivative of it, it's gone. A derivative of a constant goes away. Then if you try to work backwards, like they told us here, when you work backwards, well, there's nothing there for you to find the constant. You don't know what the constant was because it disappeared when you took the derivative. So that's the problem we're going to have. So what we're going to do to try to help with that, although the integral of f prime of x dx should be f of x, there is no way of knowing if f of x had a constant term or not. So exactly what Dan just explained. Therefore, the integral of f prime of x dx, we're going to say that's going to be equal to f of x plus c, an unknown constant that must always be added. So we don't know what c is, but we have to add c because there could have been some constant. Whether it was 0 or not, or 1, or 5, or 25, we don't know what the constant was, so that's why we have to include that c. There will be some instances with some problems we will be able to find specifically what c was, but if they just ask you to take an integral and don't ask or give any more information, you may not be able to tell what that c is, but you need to include plus c in your answer. So I'll give you a few moments to copy that all down. So far with the definition we have, does the idea behind it make sense? What we're doing the derivative backwards. So if we're given a derivative, we're able to find an original function. But again, the key point is if you had a constant term, it's gone. So that's why we denote it with a plus c. Almost caught up there, Braden? Good? All right, anybody else need a few minutes to copy that, or are we all good? All right, so let's go ahead then and move on to the first couple examples. So at the bottom of the page, they're telling us to find each of the following antiderivatives. So again, we see this is the integral of 3x squared plus 2x plus 3 dx. So we're going to follow those rules we had up above. So if you look at your rules, it says add 1 to the power of each term, then divide the coefficients of each term by the new power. So the 3x squared, if I add 1 to the power, I then have 3x cubed. It says then divide by the power. Well, the power is 3, so I'm dividing by 3. The next one, add 1 to the power. Well, that's 2x squared. The power is squared now, so divide by the power. The last one. How do I do this last one if I just have a 3 there? If you think about the steps, it says add 1 to the power, then divide by the power, but I'm adding it to my x values, or to my x's. Dan?
Technically, you have an x of 0, so you just add 1.
Exactly, it's an x to the 0, so adding 1. So I now have 3x to the first and divide by 1. You don't really have to write the dividing by 1, but we're going to write it since we're just learning. And I need to do one more thing. What is that? What can I forget? Add the c, because I don't know if there was a constant before, so plus c. Now I'm going to simplify to get my final answer. 3's cancel, left with x cubed. 2's cancel, left with x squared. And then plus 3x plus c. So you have just done your first integral. X cubed plus x squared plus 3x plus c. We took the integral of that above. All right, let's go ahead and try this one over here. So what we need to do first, we have x's on top and bottom, so we need to simplify this a little bit before we can do anything. So we need to take the integral. If I have x cubed over x, what does that simplify to? Think about these as 3 separate fractions, because we can split this up, common denominator. X cubed over x is what? X squared. So integral of x squared plus, what's 2x over x? Well, does x cancel out, so we're just left with a 2. And then minus, technically is 4 over x, but I'm going to write it as 4 times 1 over x right now, dx. So the integral of x squared plus 2 minus 4 times 1 over x dx. This now looks more like the polynomial function like we did over here, and we can actually take the integral of it now. So first step, integral of x squared, add a power, so it's x cubed, and divide by the power. So 1/3, or I can write it as x cubed over 3, or you can multiply by 1/3, it's the same thing. Again, like Daniel said in the previous problem, we have x to the 0 here, so really we end up with 2x then. Now this one's a little trickier. This one we need to think about. 4 times 1 over x. If you think about 1 over x, what can you take the derivative of to get 1 over x? Think of special functions, special rules that we learned. What can you take the derivative of to get 1 over x? It's a special function. Think you have it, Daniel?
Is it the natural log?
It is. So if the natural log, if you take the derivative of the natural log of x, you get 1 over x. But if you have 1 over x and you're trying to go backwards, 1 over x, if you go backwards and take the integral, you get natural log of x. Because if you take the derivative of natural log of x, you get back to 1 over x. So we just have minus 4 ln of x. Again, that's going backwards. We know the derivative of ln of x is 1 over x. That's why we know we can go backwards. 1 over x, the integral of that is ln of x. I'm not done yet. What else do I need to do? Add the c. Now you're going to get a lot more practice at things like that, but does that make sense where that came from? How we got that? The ln? And again, a lot of these will become second nature to you. After you do more and more practice, you're going to know these just like you do derivatives now. Derivatives you've gotten a lot better at. All right, let's look at the next example. First thing we should do is multiply these together, and then we can take our integral. So integral, multiply everything together, 2x squared plus x minus 6 dx. Once you get to this part, well, I guess I forgot to write the x, plus x minus 6. Go ahead and try to apply the rules yourself. See if you can take the derivative of this. 2x squared plus x minus 6. Try to apply those rules and see if you can come out with the integral. Sorry. Once you finish, check your answer up on the board. How'd we do? Do all right? All right, if there's no questions on that one, let's go to the next one. Looks a little different than what we've done so far. So, we don't really know how to deal with fractions yet or having anything on the bottom. Everything we've dealt with, we've made it on the top. This one, we had a fraction, but we put everything on the top. This one, everything was on the top. So, again, we want to try to put this on the top because that's how we know to deal with it now. We're going to eventually get into multiple cases, but right now, that's what we know how to do. So, we're going to set this up. We know we have a 2, integral of 2, but how can I get square root of x to the top?
You could just do 1 over square root of x like we did in the prior one. Where it's all over x. Well, not the prior one, the one above it.
Okay, what do you mean by that again? Sorry.
Like how we had the x cubed plus 2x minus 4 all over x. We divided out the x and then got a negative 4, 1 over x. You can just do.
Okay, so what would I have? The integral of 2 what?
1 over x, square root of x. 1 over square root of x.
Okay, but then I still have that square root of x on the bottom. Again, I don't know how to do the integrals yet at this point with anything on the bottom. I only know how to do them with them on the top right now. So how do I get that square root of x to the top? Yep, 2x to the negative 1/2 power. Square root's 1/2, move it to the top. So 2 times x to the negative 1/2 power. And again, dx. So the integral of 2x to the negative 1/2 dx. Now, with the x to the negative 1/2, follow your rules. You add 1 to it, so what's my new power? 1/2. So x to the 1/2. I have to divide by that power. So I have 2x to the 1/2 over 1/2. What does that simplify to? 2x to the 1/2 over 1/2. 4, and you can leave it as x to the 1/2 or square root of x, however you want to write it, plus c. Don't forget the c. 4x to the 1/2 plus c. Yeah.
Why didn't we fix the power like we did in that one for a second?
Because this is one that we should have eventually, once we go through it, memorized. 1 over x. The derivative of ln of x is 1 over x. So that's something we have memorized. On the back, when we go to that, we're going to have trig functions. Trig functions are some things you're going to have memorized. So 1 over x is just one of those things that you have to memorize. Okay. Any other questions? All right, let's go ahead to the back. So on the back, we learned that the derivative of sine of x is equal to cosine of x. And the derivative of cosine of x is equal to negative sine x. Similarly, that's not an easy word to say. Write what the antiderivatives of sine and cosine are. So antiderivative or integral of cosine x dx. So think about it going backwards. You know what the derivatives are, but think about backwards now. So the integral of cosine x is what?
Sine x.
Sine x. But it's not just sine x, it's sine x plus c. Again, we still have the constants that we're not sure about. Integral of sine x now is what?
Negative cosine x plus c.
Negative cosine x plus c. So the integral of cosine is positive sine. The integral of sine is negative cosine. Again, think backwards from the derivative. So if you think about it the other way, derivative of sine is cosine. But if you think of it backwards, integral of cosine is sine. Derivative of negative cosine is sine, but integral of sine is negative cosine. So you have to think about it backwards. It's opposite, okay? So let's try out a few examples. So at the beginning, I know it's going to be real confusing because you have derivatives in your head. You want to think about doing a derivative over and over, but you got to think backwards about it, okay? So think about the derivative, then think opposite. So find each of the following antiderivatives. So we have integral of 2 sine x plus cosine x dx. So I'm going to help you out with this one. We have sine x. Well, let's look up above. If I take the integral of sine x, I get negative cosine. I have a 2 there, though, so negative 2 cosine x. Integral of cosine is sine x. And then plus c. Okay. Now we're going to start to mix the two ideas we know. We went over trig functions and we did polynomials on the front. We're going to mix the two together. So in this second example to the right here, integral of t squared minus sine t dt. So t squared. How do I find the integral of t squared? Just the t squared part. What do I do? Stevie?
Add 1 to the power and divide by that power, so it'd be t cubed over 3.
Very good. T cubed over 3. And then if I look up above, if I take the integral of sine, but in this case there's a minus, the integral of minus sine, I would get plus cosine. And the variable is t this time, not x. Plus c. So again, we have these at the top of the page, refer to these for now, but eventually these integrals, you'll have them memorized just like you do derivatives. All right, the next one. Integral of 4x minus 3 cosine x dx. So again, we have the x first, so power up. So x to the first would become x squared, and divide by 2. I'm going to simplify in one step. 4 divided by 2 is 2, so 2x squared. Integral of cosine is sine, so minus 3 sine x. Go ahead and try the next one on your own. Again, square root though, think of that as a power of 1/2. Go ahead and try that one. Anybody want to give it a shot? Have the answer? Stevie?
X to the 3/2 power over 3/2 minus cosine of x plus c.
Okay, x to the 3/2. And you do divide by 3/2, but if I want to simplify that, what would that simplify to? Dividing by 3.
3x over 2.
Close. If you're dividing by 3 over 2, flip it over, so 2/3. So 2/3 x to the 3/2. And then he was right, minus cosine x plus c. Are we okay with that example? All right, when is this class over now? 23? Is that what time this class is over? Okay. Everybody okay with the top examples or any questions before we move on? All right, let's try to do the next example. I don't know if we'll have time to do both of them or not. We'll see how long it takes to get through one of them. It says, use the given information about f prime and f double prime to find f of x. So we want to find the original. We're given this information here. So we know that the integral of f double prime of x dx, the integral of f double prime x dx would be equal to the first derivative plus c. Again, think backwards. If you take the integral of the second derivative, you would get the first derivative plus some constant. Are we okay with that idea? So let's try to use some information we know. The second derivative evaluated at x, well, they tell us up here the second derivative at x is 2. So we know the integral of 2 dx has to equal 2x plus c. So they told me that the second derivative of x was 2, so I plugged it in. I took the integral of 2, and that's 2x plus c. So that's how I got this. Again, that tells me that the first derivative is 2x plus some constant. So now I'm going to use this information next. They tell me the first derivative evaluated at 2 is equal to 5. Okay? So I know the first derivative, f prime of x, is equal to 2x plus c. F prime of x, I know if I have the answer is 5 from up above, and I'm plugging in 2 for the x's. Again, this is just from the given information up here, so I can find c. So I found c, or the constant, for my first derivative. Again, because they gave us the given information, we were able to solve for that. Now, before I go any further, I'll recap if anybody needs to. Are we okay where we're at, or are we confused how I got 1? All right, so now I know, since I found c is 1, I know f prime of x is equal to 2x plus 1. I actually found what the first derivative was, 2x plus 1. But again, I'm trying to find the original. So now, if I take the integral of 2x plus 1 dx, if I take the integral of the first derivative, I get the original. So the integral of 2x plus 1, all in parentheses, dx. So if I take the integral of that, I get x squared. Again, I powered up and divided by 2. Well, 2 over 2 cancels away, so I'm just left with x squared. The 1 becomes plus x and plus c. The integral of 2x plus 1 is this. Now again, now I'm going to use the given information about my original at the top. F of 2 equals 10. So I'm going to say 10 is equal to 2 squared plus 2 plus c. Solve that for c. And what do you get for c? Four. So I have found exactly what they wanted me to find. I found the original function. F of x is x squared plus x from right here, plus the constant of 4. That's what we're looking for. X squared plus x plus 4. So if you were to take the derivative of this twice, you would get back to the information they give you here. The second derivative is equal to 2. If if you took the second derivative of that. Okay? So we did the integral twice to get back to the original. We okay with how we use that? Alright, so we have enough time left. I would like you to try number 2 on your own. Now I will tell you, it's the same idea, so follow the same process we just went through. The numbers might be a little trickier, so work with a partner if you have to. We'll check your answers. And the hint I'm going to give you, you're going to have negative exponents. Leave them as negative exponents in the top. Like if you get a negative exponent, don't move it to the bottom of a fraction. Play out the problem as a negative exponent, use your roles, and by the end of the problem, your answers should work out. Okay, so don't try to get rid of your negative exponents by moving them to the bottom. So give it a try and then we'll check it. Again, as you're going through this problem, you have to find a c value for your first derivative and then use it to find the original and then find your second c value. So in the whole grand scheme of the problem, you should find 2 different c values, one for the first derivative, one for the original function. Again, I know this one with the exponents is a little more difficult than the previous one. Be careful of your negative signs when you're dividing. You can start checking part of your problem. I have up to the first derivative up here if you want to make sure you've done that correctly. If you have any questions, be sure to ask. I can explain how we get there. So again, if you got tripped up with the powers here, -3/2, if you add 1 to that, that's -1.5. -1.5 plus 1 is still -1/2. Then you have to divide by that power. Divide by -1/2. Any questions on this first part so far? Were we able to find C? If you weren't able to find C, does the process make sense now that you can see it, how we found it? Are we lost, Stevie? Are you okay back there? Just think.
I think I'm okay.
Which part are you looking at, Stevie?
The negative 2x and the negative 1/2 power.
This part right here. So I added 1 to that. You're okay with getting the negative 1/2?
Oh,
And
okay.
if I divide, negative 3/2 plus 1 is negative 1/2. Divide by negative 1/2 is the same thing as multiplying by negative 2. That's where that came from. Okay? And then I'm just adding a c. So I'm just right here, I'm saying that's equal to my first derivative. Using the information here, if I plug in 4, my answer is 2. So I plug in 4, the answer has to be 2. That's how I find c. So that's for the first derivative part. And then the rest of the problem is there, finding the original. Take the integral of your first derivative, you get your original. Again, you have a plus c. That's when you use the information from up above to help. So negative 1/2 power, if you add 1 to it, you get 1/2. You have to divide by 1/2 again. Well, negative 2 divided by 1/2, multiplied by the reciprocal, you get negative 4. Integral of 3 is 3x. And again, plus c. And then just plug and chug from here to find your original function. So I know that one was a little more difficult than the first one, but I think it's helpful to have you guys go through the steps on your own instead of just copying off the board. So I know it was a little more difficult, but I think it'll help you learn the steps in the process. We have a few minutes left. Does anybody have any other questions?